For this video, we are going to cover standard form, converting ordinary numbers to standard form, and standard form to ordinary numbers. Standard form definition. You can use standard form to represent very large or very small numbers. Standard form makes use of laws of indices, but numbers are only expressed in one base, which is base of 10. A number is in standard form if it is written as a times 10 to the power of n, where a is less than 10 but greater than or equal to 1. Here are some examples of a standard form, wherein they are in the form of a times 10 to the power of n. And all the value of a right here is a is less than 10 but greater than or equal to 1. It is also in the form of times 10 with a power. It could be a positive or a negative indices. And here are the examples that is not in standard form. We have here 13 times 10 to the power of 5. It is because 13 is larger than 10. Second, we have 0.75 times 10 to the power of 4. Again, it is not in standard form because 0.75 is less than 1. Let's convert ordinary numbers to standard form. Remember, standard form is a times 10 to the power of n, where a is less than 10 but greater than or equal to 1. It's also stated here, when changing a large numbers into a standard index form, the index notation will be positive. Here's an example of a large number. We must follow that a is less than 10 but greater than or equal to 1. In that case, we need to put the decimal in between 2 and 4. From there, we have to count how many times we move the decimal. 1, 2, 3, 4. So that will be the value of your exponent or index. And that will be 2.49 times 10 to the power of 4. Next, we have another large number. So once again, a must be less than 10 but greater than or equal to 1. In that case, we need to place the decimal point in between 7 and 8. Then from there, we're going to count again how many times we move the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we move it 9 times and that will be the power or index. And our answer will be 7.8 times 10 to the power of 9. For our next example, we have 543 times 10 to the power of 5. And 543 is not less than 10 or greater than or equal to 1. So we need to place the decimal in between 5 and 4. Then count how many times we move the decimal. 1, 2. So this will become 5.43 times 10 to the power of 5. Now we're going to add 2 to the power since we move the decimal twice to the left. And that will turn into 5.43 times 10 to the power of 7. Next example, we have 1700 times 10 to the power of negative 8. The value of a is not less than 10 or greater than or equal to 1. We need to place our decimal in between 1 and 7 to satisfy that. Then we have to count how many times we move the decimal. That will be 1, 2, and 3. And then we're going to write that will be 1.7 times 10 to the power of negative 8 plus 3, since we move the decimal 3 times to the left. And that will result to 1.7 times 10 to the power of negative 5. For small numbers, when changing small numbers into standard index form, the index notation will be negative. Here we have 0.049. Now to satisfy a is less than 10 but greater than or equal to 1, the decimal point must be between 4 and 9. So we need to count how many times we move the decimal, 1 and 2. So our final answer will be 4.9 times 10 to the power of negative 2. Since it's a small number, our power should be negative. Our second example is another small number. From here, we need to place the decimal in between 8 and 2 to satisfy a is less than 10 but greater than or equal to 1. Then we're going to count how many times we move the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we move it 9 times. Our power will be a negative 9. So our final answer will be 8.21 times 10 to the power of negative 9. Next example, we have 0.0033 times 10 to the power of 7. Here, we must place the decimal in between 3 and 3. Let's count how many times we move. 1, 2, and 3. So this will become 3.3 times 10 to the power of 7 minus 3, since we moved the decimal place 3 times to the right. So our final answer will be 3.3 times 10 to the power of 4. Next example, we have 0.071 times 10 to the power of negative 11. Here, our decimal point is placed in between 7 and 1, and count the number of times we move the decimal, 1 and 2. So this will become 7.1 times 10 to the power of negative 11 minus 2. And the final answer will become 3.3 times 10 to the power of negative 13. Convert standard form to ordinary numbers. 2.9 times 10 to the power of 3. Since our power is positive, which means this is a large number. So to convert that, 2.9, we need to move the decimal 3 times to the right. 1, 2, and 3. Then the remaining spaces, we're going to write zeros. So our final answer will be 2,900. Next example, 9.1 times 10 to the power of negative 5. Our power is in negative, so which means it's a small number. To convert that, we are going to move the decimal 5 times to the left. 1, 2, 3, 4, 5. So we're going to put there the decimal, and the remaining spaces we're going to write zeros. Our final answer will be 0.000091. Pause the video and try to work it out. Which is the largest of these numbers? At the end of this video, we're going to see the answers. Comment your questions or any suggested math topic for our next video.